This first one is just basic chain rule. So you're going to do the derivative of the outside, take that 2 and bring it in front. Leave the inside alone and drop that 2 to a 1. And then multiply by the derivative of the inside. So the derivative of the inside here is going to be the -4 times the -3, x to the third, and that other -4 is going to 0 out. I don't even make you distribute, but you do need to simplify these two here. So you do get -24x cubed, and then -3x to the fourth minus 4. And you can stop there. You can distribute if you want to, but you don't have to. Trig functions are also just chain rule. So the outside here is actually the cosine. So if I were to do the derivative of the outside, I would do the derivative of cosine, which is negative sine of 4x squared. And then I would multiply that by the derivative of the inside, which is this 4x squared. So I would say times 8x. Now here, you want to actually combine whatever's in front of the trig with this little derivative here, because you can't combine that 4x squared with anything that's connected to that sign. So for this one, you would just combine that -1. If it had been anything else, you would combine it with that, like had it been sine to the third power or whatever. So you would just say -1 times 8x is -8x, and then that's times sine of 4x squared. And you're done for that one. All right, here you will use the product and the chain rule. So you have an f of x and a g of x, but in your g of x derivative, you're going to use the chain rule. So when I have something like this that I'm going to plug into a bigger problem, like derivative of the first times the second plus the first derivative of the second, I actually go ahead and find those individual derivatives first. So then I can just throw them in there. So the derivative piece of this is just going to be 12x cubed. The derivative of this guy is going to be 2 times the 4x squared minus 5 to the first power times 8x. So when I get this guy simplified, it's going to look like this: 16x, 4x squared minus 5. And when I take it all the way down, I may actually be simplifying it even more when it comes down to it. So those are my derivatives. And then I'm going to plug them into my derivative of the first times the second, you know, the first derivative of the second guy. So now that I have all those pieces, I have f of x, I have f prime of x, I have g of x, I have g prime of x. And so that's why I kind of get those ahead of time so that I don't have to do it in the process and maybe mess it up. So I'm going to do the derivative of the first, that's 12x cubed, times the second, that's 4x squared minus 5 quantity squared. Don't forget that. Plus the first, that's 3x to the fourth plus 4, times the derivative of the second, that is 16x 4x squared minus 5. And you're going to end up simplifying that guy right there because you're going to have to FOIL it. Now for this one, you don't leave it like that. Now I will say they did pull out, because it is factored form, since we had something in common here and here, I'm actually going to do both. So I'm going to pull out the 4x out of these, right? And so I have a 4x, and that leaves a 3x squared here and a 4 here. And then I'm also going to pull out a 4x squared minus 5. That pulled out one of those, and it pulled out all of that. So remember, it has to come out of all of them. So, and then you can figure out what's going on for the rest of it. Distribute your 3x squared. So you have 12x to the fourth minus 15x squared. Distribute this 4 here, plus 12x to the fourth plus 16. And then, of course, simplify that second little guy there. You don't want to leave him like that. So I have a 4x 4x squared minus 5. I have a 12x to the fourth, 12x to the fourth, 24x to the fourth, a negative 15x squared, and a positive 16. And that is factored form. So yeah, if you try to pay attention to your common factors, but it has to be in both chunks. Just like the 4x was in both chunks, the 4x squared minus 5 was in both chunks. So
I don't even want to try.
okay, so this one is implicit differentiation. They want first derivative, and you will be using the product rule here. So you need to do derivative of the first times the second, so on and so forth. You're going to have to do that throughout that piece of it. So I'm going to start right here. The derivative of the first is just negative 4 times the second, which is just y cubed, plus the first, which is negative 4x, times the derivative of the second, which is 3y squared dy dx, because I did derive a y. When I take the derivative here, that 1 zeroes out. So I'm done with this side. On this side, I just have to derive an x, so I just get 10x. It does not need a dy dx because the variables match. All right, and then I am going to get my dy dx by itself. So I am going to add the 4y cubed over. So I'll add this guy over. And I'm going to simplify this. This becomes a negative 12xy squared dy dx. Over here I have 10x plus 4y cubed. And then I divide everything by negative 12xy squared. I will say typically when you divide by a negative, they just pull it out of the numerator. So that's why your answer has your negative on top and your positive on bottom. That's almost what they'll always do. They don't have like a negative on the bottom of the fraction. They just negate the whole fraction. There's also something else you can do. All three of those numbers have something in common. What is it? 2. So you can divide everything by a 2. So this, you divide out the negative, this becomes a negative on top, and divide by 2, you get a 5x. This also becomes a negative, and that becomes a 2y cubed. And if you divide the negative out here and by a 2, that's 6xy, and that should be a squared there. I just left it off there, which is how they got that answer. I would also take positive, positive, and negative on bottom. Those are the same answers. Okay, so if you left it as positive, positive on top with a negative on bottom, that's also fine. I show you these things because the standard way of doing it is going to be this way. So on like an ACT or something like that, I want you to be able to recognize your answers. Like don't put no solution because, or answer's not there, or, you know, none of the above when your answer's actually there. So, all right, so for this one, they are asking for second derivative. So I have to do this twice. I'm going to do my regular derivative first, and this is going to be a rather easy one. So x squared is going to be 2x. 5y squared is 10y dy dx, and over here my 2 zeros out. Subtract the 2x over and divide by the 10y. So I would get dy dx. I subtracted my 2x, I divided by my 10y, and then of course I want to reduce it, negative x over 5y. All right, and now I have a quotient rule, because now I have to take this derivative again. So my derivative of my top here is just negative 1. The derivative of my bottom here is 5 dy dx, right? So when I put that into my quotient rule, I have negative 1 times the bottom, which is 5y, minus the top, negative x, derivative of the bottom, which is 5 dy dx, all over the bottom squared. And of course we can plug in this dy dx. So we can say negative 5y, this is going to be plus 5x because it's negative times a negative. And then I multiply by negative x over 5y, all over 25y squared. All right. Simplify your numerator first, probably is the best thing to do. So I'm going to bring this all the way up here to continue. So I have negative 5y plus, my 5's actually cancel here. All right, I have a negative x squared over y all over 25y squared. I need to get a common denominator. My common denominator here is y, so I need to multiply the top and the bottom by that y. So I get negative 5y squared minus x squared. That is all over the common denominator of y, and that whole thing is over 25y squared. Anytime you have a denominator over a denominator, it ends up being just multiply those, and that becomes your denominator. So my second derivative here is going to be the negative 5y squared minus the x squared all over 25y cubed. All right. And I think you can keep going here, actually. I disagree with the answer. All right, so I'm going to do something that my answer key did not do. I think I'm right here, but I'm going to take a negative out of that top. Negative 1 out of the top. I have a positive x squared, a positive 5y squared over 25y cubed. What is x squared plus 5y squared? Yeah, so I'm going to replace that whole guy with a 2. So negative 1 times 2 over 25y cubed. My final answer here is negative 2 over 25y cubed.